Hi guys, today we're doing Roman to integer. I got a request to do this problem, so that is what we're gonna do today. But before we get started, there's just a couple things I want to address real quick. So of course, I love talking to you guys and interacting with you guys, and I love when you guys comment and reach out to me. But please try to keep it on just YouTube, through the comments, or you can also DM me on Instagram. I just made my account public, so you guys can DM me on there if you have questions or want to say things that you don't want to just comment publicly. But please do not email me or DM me on LinkedIn about things related to YouTube, because I try to keep those just for jobs, and so I just don't want everything to be getting mixed up. I would really appreciate that. But that's it. So we can get started now. So they say Roman numerals are represented by 7 different symbols. So we have I, V, X, L, C, D, and M. So each symbol will represent a value. And so they say, for example, 2 is written as II in Roman numeral, which is just 2 ones added together, because the symbol I is the value of 1. So we would just put 2 of these together to get 2. And then 12 is written as XII. So X is 10, so we do 10 plus 1, which is I, plus 1 again, which is I, so that's how we get this XII. Yeah, they explain that here. The number 27 is written as XXVII, which is XX, which is 10 plus 10, so that's 20, and then V is 5, so we would add 5 to get 25, and then 2 ones to get 27. So they say Roman numerals are usually written largest to smallest from left to right. However, the numeral for 4 is not III. Instead, the number 4 is written as IV. So because the 1 is before the 5, we subtract it, making 4. So if we had VI, for example, then that would be 6, because it would be 5 plus 1. But for 4, because the I is before the V, we subtract it instead. So they say just keep that in mind. Same principle applies to the number 9, which is written as IX. So the I is before the X. So instead of, if it was XI, then it would be 11, and we would add them. But because it's IX and the I is before the X, we subtract the I instead. So it would be 10 minus 1, which would give us 9. So the only times that we subtract really is when we have a smaller number in front of a larger number. Because normally, so if it was 11, for example, it would be XI, and the X is 10 and the I is 1, and so because 10 is bigger than 1 and it's before 1, we add them. So it's only subtracting if the smaller number is first, if that makes sense. So they say there are 6 instances where subtraction is used. So I can be placed, I guess they explain it here. Okay, I can be placed before V, which is 5, and X, which is 10, to make 4 and 9. So keep in mind, right, the I is going to be smaller than V or X. X can be placed before L, which is 50, and C, which is 100, to make 40 and 90, because X is 10, remember? So if we have XL, then that's 50 minus 10, which is 40, and if we have XC, then that would be 100 minus 10, which would be 90. C can be placed before D, which is 500, and M, which is 1000, to make 400 and 900. So same concept, right? So C was 100, so we will put the C before D, so then since C is smaller, which is 100, it's 500 minus 100, which is 400, or 1000 minus 100 is 900. So they say, given a Roman numeral, convert it to an integer. So they give us 3 examples here. In example 1, we have S equals III, and we would output 3 because the Roman numeral III corresponds to the number 3. So example 2, we have this input S equals LVIII. We would output 58 because, so L, if we go back and look, is 50. V is 5, I is 1. So because it's going biggest to smallest, so 50, 5, 1, 1, 1, then we would just add them all up. So 50 plus 5 plus 3 is 58. So that's how we get that. Example 3, we are given MCMXCIV, and that's 1994 because M is 1000, CM is 900. So remember, so C was 100 and M is 1,000. So because the 100 is before the 1,000, we would subtract it instead in this case. So this together is 900. Then XC is 90 because X is 10 and C is 100. So because the 10 is before the 100, we would subtract it again to get 90. And then IV. So I is 1, V is 5. The 1 is before the 5, which is smaller than 5. So we would subtract it instead and get 4. And so then these are the numbers that we would add up instead to get 1994. So I hope that makes sense. So to represent these, map these like symbols to values, I should say, we can use a hash map. Somebody can feel free to comment below if there's a better way, but there's not one that I'm aware of, so this is just what I'm going to do. Although I know it's like not the best for space. But anyway, so we can basically just map these symbols to each of these values, and then we can loop through the string. And for each character in the string, we can just do a quick check to see what that character is, and we can do 2 at a time, I believe. Yeah, so we'll want to check 2 at a time actually. So to check if the current number that let's say we're at index 1 in this string, right? We're at C, then we want to check if C I plus 1, which would be M, is bigger than C, because like if C is smaller than it, then we want to subtract, remember? So like, but if not, then we will just go ahead and add. So we can also have our like output string that we add each of these, not string, output integer that we would add each of these numbers to. So okay, there we go. I'm just gonna use example 3 because it has like the most going on here. So I think it illustrates what we are trying to do pretty well. Okay, so let's go ahead and create the map now. So I'm gonna go ahead and say map, and we're gonna map characters to integers. And we'll just go ahead and map each of these values. So we'll just go ahead and add them. It might take me a while because there's quite a few numbers and characters that we are mapping over here. Okay, so now we've gone ahead and mapped all of our values, so we can, okay, this is, whatever, I'm not gonna do this. You guys know what the map looks like. Okay, I feel like it's just gonna take too long. Okay, so now we're gonna loop through the string. So we can say for I is 0, I is less than s dot length, I plus plus, and then actually we also want to initialize in integer for our output. So like this is going to be the number that we get in the end, which like for example 3 should be 1994. Okay, and then for every single integer, so like we start with I at 0, so we can assign a current number to whatever like number this represents to. So like M would be 1000, right? So int current is map.get s.char@I. So s.char@I is going to be this character here currently because I is 0, which is M, and then map.get M is going to give us 1000. So we are assigning 1000 to current. Okay. And then we just want to check, so if if we're not at the very end of the strings, like we're not at, say, V for like this example, then we can go ahead and check the next, like compare it to the next one to see if it is smaller than the next one. So like, for example, like C would be less than M, right? Like we want to check that if we're not at the very end, because if we're at the end, we're going to get an error because it's out of bounds. And then if it's smaller, then we want to subtract from our output. If not, then we want to add. So basically we can say, so if I is less than s dot length minus 1, yeah, so like we're at least 1 before the end, and current is less than math.get s.char at I plus 1. So that would be the next index. So at M, like we aren't going to really deal with this here because like this isn't a case where we're subtracting it. We will in the next one, so I can show you with that one. But like, let's just say we're here, right? So like I is 0, I plus 1 is going to be 1. So s.char at I plus 1 is C. And then map.get C is 100. That's the value. So we're going to check if current, which is 1000, is less than 100, which it's not. So we're actually not going to go into this if statement yet. And that should not be a semicolon. Okay. Yeah, so if this is the case though, so like let's say it's the next one actually. So like let's say I is currently 1, and that would mean that current would be 100. Right, because, yeah. And then I plus 1 would be 2, so then s.char at I plus 1 would be M. And then if we get that in the map, that is going to give us 1000. So then if current, which is 100, is less than 1000, which it is, and we're not at the end of the string, obviously, then we will want to subtract this value, so C, from our total output. So output minus equals current, right? Because current is 100. Like we don't actually have to do it this way where like I mean you can if you want, but like I feel like it's a little bit easier to not do it this way, where we like add up these numbers or like subtract it from here and then like add the total into the thing. Like you can do that, but like I feel like that's just kind of overcomplicating it a little bit, for me personally at least. Like we can, like it's the same thing as if you just like, if we have 1000 so far for M, then like 1000 plus 900 is the same thing as 1000 minus 100 plus 1000. Like do you get what I'm saying? So like if 1000 plus 900 is what they're doing here basically, right? Like their way, but like I'm saying like we can also, like if we have 1000 for current right now, because okay, well if it's not this, like output plus equals current, that's what we're gonna do, because output starts at 0 and then at the first time it's not less than the next one, so we can go ahead and just add it to current. So then current is going to be not current, output is going to be 1000 now because we just added current to it. Okay, so now we have 1000, and then the next iteration, then we have C is, what was C again? C is 100. So because it's less than the next one that comes after it, which is this M, then we know we're not actually going to be adding C, right? So we can just subtract C, which is 100, and then the next iteration when we get to M, we can just add M back, and M is 1000, right? So like this equals 1900. This also equals, like, because 1000 minus 100 is 900, plus 1000 also gives us 1900. So this is the same thing. So I'm just doing it this way instead, but they're going to get you the same, the same, why can't I speak? Oh my god. They're going to get you the same value in the end. There we go. I hope this is making sense and it's not like all over the place, because I feel like my explanation was kind of confusing. Okay, so yeah, basically we're literally just going to do this for the entire string. I can walk us through it if that would be helpful. If not, then sorry. I don't know. I guess just skip ahead. basically, okay, so like let's keep going. So we now have, okay, well now output is going to be 1900 and we are at I equals 3. Okay, and then so actually, okay, so we're at I equals 3 and then current is going to be map.get s.char at I, char at, or 3, I is 3, so s.char at I is going to be x, okay, and then map.get x is going to give us 10, and so we want to check if, so we're not at the end of the string yet, okay, and then current, which is now 10, is we're going to check if that's less than this. So this is going to be, so I is 3, so I plus 1 is 4, and then s.char 4 is going to be c, so then map.get c is 100. So is 10 less than 100? Yes, it is. So we're going to subtract 10 from our output. So our output is now going to be 1890. I hope I did that math right. Yes. Okay, so then that is that, and then we continue on. So now I is 4. At 4 we have C, so this is going to be 100, because that's what C maps to. And then we're not at the end of the string yet, so that's good. And then current is 100, so we check if 100 is less than basically just the next value in the string, which is I. And I is 1. So 100 is not less than 1, so we just go to the else and add our current value, which is 100, to our output. So now we have 1990. Okay, next iteration, then I is 5. 5 is I, so this is going to be 1. And then we are still not at the end of the string yet, so we're good. And then we check for current, which is 1, is less than the next value, basically, which is 5, and it is. So 1 is less than 5, right? And so we're going to subtract 1 from our output to get us 1989. Then our next iteration, because we skipped the else then because we already did the if, I is 6. And now we are at the end of the string, so there's nothing after it, so like we can't actually do this if statement because we're at the end of the string. So we just go to else, and then we output plus equals current, and current, oops, my bad, is 5 because that's the value of v in Roman numeral, right? Like we can see that v maps to 5. So then we just add this to output, and then 1989 plus 5 is going to be 1994. And then once we've done all that, then we can just go ahead and return our output, and that should be it. So let's test this out. All right, so our time complexity, let's take a look at what we did. So this is just this is just adding all of our Roman numerals to the map, which is basically just constant, because like this is just a set number of Roman numerals, so it doesn't really matter. And then the bulk of it is going to be in this for loop, which we are just iterating through each character in S, which is our input string, and checking characters against each other, basically, like in the map, which is a constant. So like it's really just like looping through the string n times, where n is the number of characters in our string. So that's going to give us a time complexity of O of n, where n is the number of characters in our string S. Okay, and then space complexity. So our only data structure here is this hash map, as we can see, and this is, I guess this is technically constant, because we're not storing like all of, like it's not proportional to S really, it's just like a constant number of Roman numerals. So I guess technically we could say our space is constant. Yeah. That's kind of interesting. But that's it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!